What if you could have an expert watch over your 3D printer, catching every single tiny mistake as it happens and fixing it on the fly? Well, that's not science fiction anymore. Today, we're diving into some incredible research that's created an AI supervisor for 3D printing. Let's get into it. 3D printing, or additive manufacturing, feels like pure magic, doesn't it? You take a digital design on a computer and poof, you build it layer by painstaking layer into a real, physical object you can hold in your hand. This stuff is completely changing the game in so many fields, from custom medical devices in healthcare to super complex, lightweight parts for aerospace. Honestly, the potential feels just about limitless. But, and this is a big but, anyone who's ever used a 3D printer knows the dark side of that magic. You know the feeling, right? You let a printer run for hours, maybe even days, and you come back to find this tangled, nightmarish mess of plastic spaghetti. Failed prints are unfortunately a very common and very frustrating reality. And look, this isn't just a thing that happens to hobbyists in their garages. It is a massive hurdle for serious industrial applications. And when you look at the numbers, they're kind of staggering. According to some studies, the overall failure rate for 3D prints can be as high as 41.1%. That is almost half. Think about all that wasted time, all that wasted energy, and all that expensive material just gone. These failures pop up in all sorts of ugly ways. You've got stringing, which leaves these little plastic cobwebs all over your model. You've got warping, where the corners of the print curl up and detach from the bed. And then there's under extrusion, where the printer doesn't push out enough plastic, leaving you with parts that are weak and just fall apart. All these defects make it really, really hard to trust 3D printing for parts where failure is not an option. So, people have tried throwing AI at this before, right? But those earlier attempts, they had some pretty major drawbacks. They were way too rigid, and they needed an absolutely massive amount of data to even get started. And that brings us to the really key difference here. Traditional AI models, the old way of doing things, needed to be trained on these huge, perfectly labeled datasets of thousands of failed prints. They'd become an expert, sure, but only on one specific task, on one specific printer. They couldn't adapt. This new approach, using a large language model, or LLM, is a whole different beast. It doesn't need all that pre-training. It can generalize to new machines and materials, and it literally learns and adapts as it goes. Okay, so that brings us to this absolutely brilliant solution from the researchers at Carnegie Mellon. They've built a system that uses a big brain, an LLM like GPT-4o, to act as an autonomous supervisor for the whole printing process. The best way to think about it is like having a master craftsperson, a real expert, standing over the machine's shoulder 24/7. It's a whole system of AI agents working together, but the LLM is the boss. It uses a couple of cameras to watch the print, it reasons about what it's seeing, and then it tells the printer exactly how to adjust to fix any problems it finds, all in real time, layer by layer. So how does it actually work? Well, it's this really elegant and surprisingly simple loop. See, think, and act. Let's break it down. First up, the AI sees. After every single layer is finished, everything pauses for a second. Two cameras, one looking down from the top and another from the front, snap a couple of pictures. This gives the AI a complete 360-degree view of how the print is doing right at that moment. Next, it thinks. And this is where the real magic happens. The LLM looks at the new pictures and compares them to the last ones. It spots problems, a little bit of stringing here, some poor wall quality there, and it doesn't just see the problem, it reasons about what might be causing it. Then it comes up with a detailed, step-by-step plan to fix it. And what's so cool is that this isn't some black box we can't understand. The AI is literally thinking out loud. It might say something like, okay, I'm seeing visible stringing and the extrusion looks inconsistent. My plan is to increase the flow rate by 10% and tweak the retraction settings to be a bit faster. It's totally transparent. And finally, it acts. The LLM takes its plan and translates it into G-code, which is basically the language that 3D printers speak, and sends those new commands straight to the printer's brain. It can change the nozzle temperature, the printing speed, the amount of plastic coming out, anything it needs to make sure the next layer is better than the last one. So, the big question is, does all this actually work? Oh yeah, the results are, well, they're not just a little better, they are absolutely dramatic, both in how they look and how they perform. I mean, just look, when you put a standard print next to one that was supervised by the AI, the difference is just night and day. The normal print has all these rough edges and sloppy layers. The one optimized by the LLM, it's clean, it's smooth, it's precise. It just looks right. But here's the real kicker. This isn't just about looking pretty. These improvements have a huge impact on the part's physical strength. The researchers put these parts into a compression tester to see how much force they could take. The standard part failed at about 0.8 kilonewtons. The AI-optimized part, it held on all the way to 4.0 kilonewtons. Just think about that for a second. The part that the AI supervised was over 5 times stronger. That is a mind-blowing leap in performance, and it was achieved just by making smart little corrections during the print. Incredible. Okay, so this is obviously super cool, but it's about way more than just fixing hobbyist prints. This research is really pointing toward a fundamental change in the future of how we make things. I mean, the implications here are massive. First, you're going to drastically reduce waste. Second, you're finally making 3D printing reliable enough for those super critical parts in airplanes or medical implants. This is also a huge step toward the idea of a smart factory that can pretty much run itself. And because the AI logs every single decision it makes, you get this perfect paper trail, which is a game changer for quality control and getting parts certified. So, if you take one thing away from all this, let it be this. This project isn't just about making an AI that's good at 3D printing. It's really a proof of concept for a much, much bigger idea. We are successfully teaching an AI to watch a physical process, to understand when it's going wrong, and to physically step in and correct it, all by itself. We are giving AI eyes to see, a mind to reason, and hands to actually fix problems in the physical world. This research is pulling AI out of the digital world of just text and images and putting it into the real physical world of atoms and manufacturing. It really leaves you with a fascinating question, doesn't it? If an AI can master all the messy complexities of a 3D printer today, what physical process is it going to perfect for us next?